Okay, so in this unit we are working with systems of equations, not just one equation anymore, but we might have more than one equation that we're trying to solve together. So what I would suggest, since this method uses graphing, that you need yourself some graph paper. You might go on my website and print out some graph grids that have some little extra space so that you don't have to go through the trouble of drawing your x and your y axis. It'll already be drawn for you. So objective 1, we're solving a system of equations by graphing. Okay, so that's why we need some graph paper. Number 2, we're classifying the system as either a consistent, which is independent or dependent, or inconsistent. And you may not know what that is yet, but it's very, very simple. It's just depending on whether the graphs intersect or they don't. Okay, and then finally, we're going to look at stuff from 3.3. Kind of goes with this since it's about graphing. We want to be able to solve a system of linear inequalities. So now we have inequalities in two variables with y's and x's. Alright, so let's take a look at this first objective, being able to solve a system of equations by graphing. In this image, you can see maybe these things are missiles. I'm not sure. Maybe they're jets or something with some vapor trails there. And you can see right here in the picture, looks like this is where they would have intersected, but somebody changed some trajectory right there, fortunately. But this is exactly what we're trying to find whenever we solve a system of equations. Where would those things touch each other? Where would they intersect? So a system of equations then is a set of equations, a collection of equations, two or more of them, that all have the same variables. So for us, maybe x's and y's. And as you'll see down the road, we might have x's, y's, and z's. Okay? So whenever we solve a system of equations, we're looking for, the solution is a point, an ordered pair that satisfies all of the equations in the system. Okay? So it works in the first equation, it works in the second equation, and if there's more than that, it works in the third, and so on. In general, if you have two variables, you have x and y, then you need two equations to solve it. As you'll see at the end of this unit, when we have three variables, x, y, and z, this means that you need three equations to solve it. So in general, however many variables that you have, in order for the system to be solvable, for you to find that, that solution, you need an equation for each one of those variables. So here is what a system of linear equations look like. And you can see that this just looks like they're in standard form. They don't have to be in standard form, that's just how these look, where the A, B, C, D, E, and F are just some numbers, right? So when we solve this system, we are looking for the single point x, y that they both have in common, right? It satisfies the top equation and it satisfies the bottom equation. All right, now I would like for you to get out your graphing calculator, because in this investigation we're going to use the graphing calculator and we're going to use the table on it in order to solve a system of equations. We're trying to find out where the x and the y are equal to on both of the equations. So I'm going to assume that you have your calculator out. If you don't, why don't you pause and go get it? And if you have it on your computer here, just open up that emulator and let's get started. Okay, so once you get that calculator open and turned on, go to y equals, and we're going to type in two equations. So just like you see it here, y1 type in 2x plus 4, and then y2 type in negative 3x plus 44. Okay, so all we did is we typed in our two equations. Now, instead of going to the graph menu, we're actually going to look at the table. Before we go to the table, though, we're going to make sure some things are set correctly under the table setup. Okay, so step 2, go to second table. You don't want to hit table, you want to hit second table. And this is the table setup menu. All right, so whenever you pull this thing open, you can see, whoa, hey, back this up. You can see that it will start at 0. That's usually what it defaults to. And delta table means what the table increases by, the x value. So if you start at 0, the next one would be 1, and then 2, and so on. If, for example, when we get done with this and we don't see a a point that they have in common, I can come back to this screen and I can change delta table to something like 0.5. So it would go 0, 0.5, 1, 1.5, and so on. Okay, so once we have these things set up, let's go ahead and hit the table button. So click the table button, and this is what I should get. I should try to scroll down until I see where the x value, where the two y values are the same. So keep scrolling. You might have to go up, you might have to go down. You're looking for where y1 is equal to y2. The y values are the same. So this is what it should look like. You should scroll down basically to the number 8. When you get to the number 8, you can see that y1 is equal to 20 and y2 is equal to 20. In other words, the solution to this system of equations is the point 8, 20, because that is a solution of both of the equations. It works in both of them. Okay? So what I want you to try to do is I want you to try to do this yourself on this next exercise here. So do the same thing, go to y equals, and here are your two new equations. Find that in the table, find where the y1 and the y2 are equal to each other, and then write down the point that they have in common. Alright, so you probably had these things typed into your calculator like so. So I have y1 is 2x plus 5, and then y2 I put negative x plus 2. Okay, so if you were having trouble on the previous one trying to find out where all of those buttons were, if I'm going to table set, to just set up the delta table and what it starts by, whoops, I'm going to go to second window. Right above that in blue it says table set. Okay, so right now it says I'm starting at negative 2. Maybe I want to start that thing at 0, and I'm going up by 1. And what I said before is if I don't see it when it's going up by 1, I might come back here and change that thing to half or maybe a quarter. All right? So now I'm going to go ahead and go to table, which is right above the graph key. So I hit second graph for table. Now I'm going to scroll up or down in order to see where the two y values are the same for a given x value. So I can see I don't see anything on the screen right now. I can keep scrolling down. I don't see anything on the screen, and it looks like they're just getting further and further away. So maybe I scroll the other direction, and oh, there it is. I can see that the point that they have in common is negative 1, 3. So this means that the point of intersection, or I should say the solution to this system of equations, is negative 1, 3. Okay, so negative 1, 3 works in both of these equations. Just take a look here. So if I stick in negative 1 into this top equation, I get 2 times negative 1 plus 5. That is a negative 2 plus 5 equals 3, right? If I stick negative 1 into the bottom equation, I get negative of negative 1 plus 2. That is a positive 1 plus 2, which is 3. And I can see that it works in both of the equations, giving me the same answer. That's the solution. Okay, let's do one more thing on the calculator there. So what we were doing is we were just looking at the table. Let's go ahead and now look at the graph. So just hit the actual graph button, and this is what the two equations would look like. And look for that point negative 1, 3 on the graph. So negative 1, 3, that is the point at which these two lines cross each other, where they intersect. And so geometrically, when I'm solving a system of equations, what I'm looking for is the point that they intersect, their point of intersection. And that's what this next video is about, and us doing all of this stuff by hand instead of on the calculator.